Well, folks, it's just kind of the nature of our content. Here we are in part 7, and it's finally time to actually subnet. Yes, let's go ahead and jump in. I think this is the moment you've been waiting for, and you're going to love this content. So let's subnet a Class C address. Here it is. It's that kind of famous address for our series that I got off my laptop, 192.168.0.18, with a standard, classic, natural, default subnet mask of 255.255.255.0. Let's think about prefix notation for a moment, and let's get rid of my .18 host address from my laptop. So the network is 192.168.0.0, and it is a 24-bit mask. So /24 for prefix notation. All right, well, let's engage in the subnetting process, and we begin by, of course, having our handy-dandy conversion chart in front of us. But notice the question we're asking. How many subnetworks do we need? Yeah, how many subnetworks do you want to create out of your one Class C 192.168.0 network? Let's just say we think about this and we think 4 subnetworks would be wonderful. So how many bits do we need to use for subnetting? The answer is our formula, 2 raised to the 2 in this case. We need 2 bits. Yeah, if we use 2 bits of additional subnet masking, so to speak, we can create 4 networks. We learned this 2 to the n formula in an earlier video, as you remember. So if we go ahead and borrow or steal 2 bits for subnetting, for creating subnetworks, we're going to be able to create 4 networks. So our mask was 255.255.255.0. We are now going to extend that mask by 2 bits, and that would be in decimal 128 plus 64. That's our 192. So there is our new mask. Our mask will be 255.255.255.192. And this scheme will allow us to create 4 additional networks. By the way, from a prefix notation standpoint, notice we're going to be stealing those 2 bits. And so we're going to have a /26 mask. Now, the next question we would ask is, okay, love it, great. I love that I could create 4 networks here, but how many hosts per network can I accommodate? Well, think about it. If we have a /26 now, and there are 32 total bits, 32 minus 26 leaves us just 6 bits for host addressing. Remember, the formula for how many hosts we can have is 2 raised to the number of host bits minus 2. So sure enough, 2 raised to the 6 is 64. And if we subtract 2, we can have 62 hosts per subnetwork. So I love it. This /26 mask is going to give us 4 networks, and each network can have 62 hosts. This sounds perfect for a small office environment that wants to create its 4 subnetworks. I love it. Now, what are these subnetworks? And it's at this point in the video where I am going to teach you a mathematical trick that works every time that you are going to love. And it's the first time we've encountered this, so you haven't seen this in any other video we've created for you. What we're going to do is figure out the increment or block size. And how this works is you look at how many bits you went deep in your subnetting, and we know that was 2 bits. And we know we have to do them from the left to the right. So in that fourth octet for the subnet mask, we did 1, 1, and then, of course, all zeros. So how deep into that fourth octet did we go? Well, right there, we went that deep into that fourth octet, and that tells us that our increment size or block size is 64. So now we can build our subnetworks. It's going to be 192.168.0.0 is our first subnetwork, and then our second is 192.168.0.64. Notice it's the block size. Yeah, it's the increment size. And then our next one will be 192.168.0.128. That's 64 plus 64, of course. And finally, 192.168.0.192. 128 plus our block size of 64 gives us 192. So those are the 4 subnetworks. Those addresses are not usable. We can't assign those to host systems, and that's because they identify the network itself. Yeah, it's all zeros in the host bits. So these are the network identifiers for our 4 networks. We won't be assigning these to host systems. And that leads to our final question when we are calculating subnetting like this, and that is, what are the possible host addresses? So we begin with 192.168.0.0. We can assign that to a host, but we can assign the very next number in the scheme, and that would be 192.168.0.1. Yeah, we could give that to a host. And this would go all the way up to 62.62. What happens to .63? It's the broadcast for that subnetwork. And then what happens to .64? Well, that's the next network. So what are its addresses that are possible? 192.168.0.65. And then we're going to go up to 128, but we have to back off 127 for the broadcast. So it's 126 would be the last addressable host on that network. What's the next network? It's 192.168.0.128. So our first usable would be .129. Our last usable would be .190. .191 is the broadcast, and 192 is our next network. And finally, that would go from 193 to 256. That's not even possible for a network. 255 is the broadcast. So one less from that is the last usable host address on the .192 network, and that is .254. Now, this is all wonderful, and we're going to do more practice, and you will be practicing. But one question you might have is, Anthony, how can I check all of this work we just did? Well, sure enough, there's a very easy way you can check all of this work. And too bad you can't do this in the exam, but you're just going to go to an IP subnet calculator. Yeah, you'll quickly decide on your favorite one, and you'll go ahead and go in and say, okay, I have a class C of 192.168.0.0, and I want to use a /26 mask. Go ahead and calculate this for me, and notice it's going to give us our 4 networks, the broadcast addresses for those networks, and the usable host range. So you are going to be able to check your work, of course, with an IP subnet calculator. Well, I hope you're loving this, and I hope you'll be back for more practice, and we have to do subnetting of Class B and Class A networks, of course. So I hope you'll join me for all of this practice.